Okay, so let's understand about bias and variance. Okay, variance. Okay, so I'm not going into the definition part or understanding about maths and all those things. I will keep it very simple. And the thing that you need to understand, okay, what is the concept behind it? I'm not going to any kind of like telling about the definition, all those things. Okay, so let's get started with bias. Okay, what bias is actually? Okay, so bias is nothing but it is the error. Okay, you could say that because what bias is actually is the difference between the predicted and the actual value. Okay, bias is nothing but the difference between predicted and actual value. Okay, so this is our predicted predicted value y hat and this is our actual value. Okay, so this is a difference, and what we know about the difference between, okay, so difference of the actual and the predicted value we often call as error. Okay, and if anything is equal to this, then we can say this that it is an error. Okay, so bias is simply nothing but simply an error. Okay, that now we know that if we train suppose this is our data. Okay, this is our data. Okay, now if we plot our prediction line, okay, the fit line, this is okay, if it gives low error, okay, if it gives low error, which means a good model. Okay, good model. Lower the error, better the model. Higher the error, okay, high error, we can say that this is not a good model. We could say that it is a bad model. Okay, we can say this. So low error means good model. What does it mean if we say the low error? That it is uh, giving the minimum error. Okay, it is giving the error, but it is minimum than each and every error that we have uh, dealt earlier. Okay, so low error means good model and high error means bad model. Okay, now we can apply this here also, like low bias means a good model. Okay, and high bias, okay, high bias means a bad model. Okay, bias means error. If it is giving a high error, it is a bad model. And if it giving us low bias means low error, it is a good model. Simple as that. Okay, so if we say that, then we have a training data set and we gave it to the model. This is our model. Okay, suppose it is actually a machine. Okay, if it will have two scenarios. Okay, it will first give us low error, which means low bias. Okay, and it will give us high bias. High bias simply bad model. Okay, and this is a good model. Simple. So that was about bias. Now going about variance, what actual variance is? Okay, so I'm not going into about what variance is actually. We know that in mathematics it is the difference between the mean and its each data point. But in the ML, okay, I'm not going into definition, but I will just tell you that if we train on sorry we test on we trained on a training model, now we tested. Okay, if testing data, okay, if testing data is given to the model, okay, it will have two scenarios, that it will perform well on the training testing data, or it will not perform best on the good on the testing data. Okay, so if our model is a good model, then it will fit uh, good in the training testing data set. Okay, so it will have two scenarios. The first is it will give us low error. Okay, in the testing data set also we will have two scenarios: high error and low error. Okay, low error. High error means high variance. Okay, in the testing data. Okay, and low error means low variance. Simple. Okay, so we need to understand a thing, that we gave training data to the model. This is our model, okay, and it will give us two scenarios, okay, low bias and high bias. Now we have another scenario in which now we have trained our model. Now we need to fit or give some data which is unseen data, okay, on the model, and we need to test the data at how well it is working, okay. Now we have given it to the model. Now based on the results, we have two scenarios, okay. The testing data is given to the model, and now we have two scenarios. The first one is actually that it has performed well also on the testing data, then it will have a low variance, okay. And if it has not performed well on the testing data set, okay, then it will have a high variance, okay, high variance. Simple as that. Now there is a two another concept which we also know which is also known as underfitting and overfitting, okay. Underfitting and overfitting, okay. So let's understand all what these all are, okay. So suppose this is our data, okay, data points like this, okay. This is our data set, training data, what we'll name it here, training. Now fit a model like this, okay. Is it fitting well on the data set? If you see, is it fitting well? See, there is a lot of data set which has been left, and there is a high error. See, there is this much of data set has been, you know, not fitted well on. So this is actually a linear model, but it has not fitted well on this data, okay. And if it is not fitted well, okay, so what it will do is that it will try to overly fit, okay. If I tell you, then this is our the first try, okay, this is our first try that our model tried to fit but it couldn't fit. Now we will have another scenario in which it will try to fit all the data, okay, like this. It will try to fit all the data set like this, okay, like this, okay. These all are fitting, this line is also fitting, and this line is also fitting, okay. This line is fitting, but it is giving us actually high error. High error means high bias on which training data set, okay. And this model is also fitting, it will give us a minimal, like low, very low bias, but it is actually overly fitting. It is actually this is overly fitting, which we doesn't want, because if it fits very overly, very it will fit overly, then we won't have, you know, pattern, okay, actually, because it has covered all the noises, okay. All the pattern doesn't follow any pattern, because which kind of algorithm is like this which follows this pattern, okay, this, none, okay. We need to find a pattern that if we find because if we get the pattern, then on any unseen data set we can use that pattern, and we can get a new, okay, we can get a new prediction, okay. So we have two scenarios, low and higher, high bias, okay. Now this is not the scenario, okay, this is a scenario and it is giving us a low, okay. So this is we call as overfitting, okay, overfitting, in which the model is fitting overly, and it is getting, okay, it is uh, trying to fit all the data points, but it couldn't. So it will be a low bias. Why? Because it is giving minimal error, it is giving us minimum, okay, minimal error, which doesn't any count, okay. Now this model, if you train on the testing data set, okay, testing data set, it won't perform well, because it didn't get any kind of pattern. It does not have any kind of pattern like this or like this, okay. If we have pattern like this, okay, this is actually, we can say, a quadratic, okay, this can be a pattern also, okay, but it is not even like this, it is like this. How can this be a pattern? Okay, so it will perform not good on the testing data set, so it will have a high variance, okay. Got it. Now we have underfitting. In underfitting, the model could not even fit on the training set, Okay, it will be like this, like as I talked in the earlier scenario, it will be like this. Okay, so we have the data set like this, like this. Okay, and now the model is like this. So this is what we call underfitting, in which the model is could not even fit on a good scenario. Okay, could not even fit and cannot even give a good prediction on it. Okay, so this is what we call underfitting. Underfitting, simple, in which we'll have high bias. Why? Because it will give us much error. See, it is simple. Like if it is not fitting well, then it will give a very high error, because see, the data point is like this. Okay, and it will give us a very high error like this. Okay, see this, like this. So it is giving a much error. That's why it will have a high bias, and it will have a low variance. Okay, now there is a doubt also, that if you would have a doubt, if you didn't had any doubt, then there is a mistake or something like that. But yeah, question is that I'm giving you homework. Okay, that if the model could not fit on the training set. Okay, this is our training. If our model could not perform well on the training dataset, then how it can perform well on the testing dataset? Tell me. So it should have a high bias, and so it should had high bias and high variance, but is not the scenario. Okay, so this is what it is. So let me summarize what have we told is that on the training dataset. Okay, if we give to the model. Okay, and model will have two scenarios. The first one is like low error, or we could say that low bias, simple. Okay, or high error or high bias. Low error means good model. Okay, and high error means bad model. Okay, now on the testing, we have a model, and it will give us two scenario, that it can predict well. Okay, so it will have a low variance or low error, simple. Okay, and it will have a high variance or high error. Okay, so we can say that here is that it is a good prediction, and it is a bad prediction. Okay, now in the overfitting, that model try to fit overly, so it will have a low bias, that it is giving us minimum error, like minimal error. Okay, and it is not performing well on the test dataset, because it did not get any pattern on the training dataset. That why it is not performing well on the on the testing dataset. And if it couldn't perform well on the testing dataset, then it is have a bad prediction. Okay, now when the model is underfitting, simply it will have a high bias. Okay, and it will have a low variance. Okay, why high bias? Because the model couldn't even fit on the training dataset, and if it couldn't fit on the training dataset, then how will it uh, perform well on the testing dataset? Okay, so that was the thing. That if you have any doubt, you could ask me in the comments, or you could join the Discord also. Okay, if you want, or you should not want, you should. Okay, so that was the thing, and yeah, I think you would have cleared your doubt. Okay, bye bye.